Hello students, in today's session let us learn about acid rain and ozone layer depletion. Acid rain: when fossil fuels such as coal, oil and natural gas are burned, chemicals like sulfur dioxide and nitrogen oxides are produced. These chemicals react with water and other chemicals in the air to form sulfuric acid, nitric acid and other harmful pollutants like sulfates and nitrates. These acid pollutants spread upwards into the atmosphere and are carried by air currents to finally return to the ground in the form of acid rain, fog or snow. The corrosive nature of acid rain causes many forms of environmental damage. Acid pollutants also occur as dry particles and gases, which when washed from the ground by rain add to the acids in the rain to form a more corrosive solution. This is called acid deposition. Damage from acid rain is widespread in North America, Europe, Japan, China and Southeast Asia. In the US, coal burning power plants contribute to about 70% of sulfur dioxide. In Canada, oil refining, metal smelting and other industrial activities account for 61% of sulfur dioxide pollution. Motor vehicle exhaust fumes are the main source of nitrogen oxides. The acids in acid rain chemically react with any other object they come in contact with. Acids react with other chemicals by giving up hydrogen atoms. Now, let us see what are the effects of acid rain. Acid rain is known to cause widespread environmental damage. The first point, acid rain dissolves and washes away nutrients in the soil which are needed by plants. It can also dissolve naturally occurring toxic substances like aluminum and mercury, freeing them to pollute water or poison the plants. The second point is acid rain indirectly affects plants by removing nutrients from the soil in which they grow. It affects trees more directly by creating holes in the waxy coating of leaves, causing brown dead spots which affect the plant's photosynthesis. Such trees are also more vulnerable to insect infestations, drought and cold. Spruce and fir forests at higher elevations seem to be most at risk. Farm crops are less affected by acid rain than forests. The third point mentions about the acid rain that falls or flows as groundwater to reach rivers, lakes and wetlands causes the water in them to become acidic. This affects plant and animal life in aquatic ecosystem. The next point states that acid rain also has far reaching effects on wildlife. By adversely affecting one species, the entire food chain is disrupted, ultimately endangering the entire ecosystem. Different aquatic species can tolerate different levels of acidity. For instance, clams and mayflies have a higher mortality when water has a pH of 6, while frogs can tolerate more acidic water. Although with the decline in supply of mayflies, frog populations may also decline. Land animals that are dependent on aquatic organisms are also affected. The next point states that acid rain and dry acid deposition damages buildings, automobiles and other structures made of stone or metal. The acid corrodes the materials, causing extensive damage and ruins historic buildings. For instance, the Parthenon in Greece and the Taj Mahal in India have been affected by acid rain. The next point mentions, although surface water polluted by acid rain does not directly harm people, the toxic substances leached from soil can pollute water supply. Fish caught in these waters may be harmful for human consumption. Acid, along with other chemicals in the air, produces urban smog, which causes respiratory problems. So, what are the solutions for these acid rain. The best way to stop the formation of acid rain is to reduce the emissions of sulfur dioxide and nitrogen oxides into the atmosphere. This can be achieved by using less energy from fossil fuels in power plants, vehicles and industry. Switching to cleaner burning fuels is also a way out. For instance, using natural gas which is cleaner than coal, using coal with lower sulfur content and developing more efficient vehicles. If the pollutants have already been formed by burning fossil fuels, they can be prevented from entering the atmosphere by using scrubbers in smokestacks in industry. These spray a mixture of water and limestone into the polluting gases, recapturing the sulfur. In catalytic converters, the gases are passed over metal coated beads that convert harmful chemicals into less harmful ones. These are used in cars to reduce the effects of exhaust fumes on the atmosphere. Once acid rain has affected soil, powdered limestone can be added to the soil by a process known as liming to neutralize the acidity of the soil. Now, let us discuss about the ozone layer depletion. Ozone is formed by the action of sunlight on oxygen. It forms a layer 20 to 50 kilometers above the surface of the earth. This action takes place naturally in the atmosphere, but is very slow. Ozone is a highly poisonous gas with a strong odor. It is a form of oxygen that has 3 atoms in each molecule. It is considered a pollutant at ground level and constitute a health hazard by causing respiratory ailments like asthma and bronchitis. It also causes harm to vegetation and leads to a deterioration of certain materials like plastic and rubber. Ozone in the upper atmosphere, however, is vital to all life as it protects the earth from the sun's harmful ultraviolet radiations. The ozone layer in the upper atmosphere absorbs the sun's ultraviolet radiations, preventing it from reaching the earth's surface. This layer in the atmosphere protects life on earth from the dangerous UV radiations from the sun. In the 1970s, scientists discovered that chemicals called chlorofluorocarbons or CFCs, which were used as refrigerants and aerosol spray propellants, posed a threat to the ozone layer. The CFC molecules are virtually indestructible until they reach the stratosphere, where UV radiation breaks them down to release chlorine atoms. The chlorine atoms react with ozone molecules, which break down into oxygen molecules, which do not absorb UV radiations. Since the early 1980s, scientists detected a thinning of the ozone layer in the atmosphere above Antarctica. This phenomenon is now being detected in other places as well, including Australia. Although the use of CFCs has been reduced and now banned in most countries, other chemicals and industrial compounds such as bromine, halocarbons and nitrous oxide from fertilizers may also attack the ozone layer. The destruction of the ozone layer is seen to cause increased cases of skin cancer and cataracts. It also causes damage to certain crops and to planktons, thus affecting nature's food chains and food webs. This in turn causes an increase in carbon dioxide due to the decrease in vegetation. With the signing of the Montreal Protocol in 1987, a treaty for the protection of the ozone layer, the use of CFCs was to be banned by the year 2000. After 2000, the ozone layer is expected to recover slowly over a period of about 50 years. So, in this session, we have learnt about the acid rain and ozone layer depletion. Hope you have got a good insight on some details about the acid rain and ozone layer depletion. Until we meet again, bye.